Hi everyone, my name is Brock Cardwell-Teben, and today I'm going to be presenting a very common yet innovative piece of technology, which is the microwave oven. So you've probably used one today, or at least within the week, without really thinking about how it works. But the microwave is actually a brilliant example of how science, technology, engineering, and math, or STEM, all come together in one device. So on my slide, here is a picture of a microwave that I might use at home. Mine kind of looks a little different as well. And as you look at my presentation, I hope you're seeing this everyday application in a new light. So let's go into my first slide. So let's start with the science behind a microwave oven. Microwaves use electromagnetic radiation, which is a part of electromagnetic spectrum. The specific frequency used is roughly what I found 2.4 gigahertz. It's between radio waves and infrared lights. These waves are able to pass through and make any material like plastic or glass get absorbed by water, fats, and sugar in the food. When the microwave energy hits these molecules, it makes them vibrate really fast. So they kind of shake. The vibration creates heat, which is called dielectric heating. It's not like a traditional oven that heats from the outside in. Instead, the food is being heated internally by the molecules itself. So really, when you are microwaving leftovers or any food, the exciting water molecules that are in it make heat from inside out. So my third slide is the technology behind it. So we're going to talk about the technology of a microwave. A modern microwave oven was actually invented by accident in 1945 by a man named Percy Spencer. He was an engineer that was working with radar equipment. He noticed that a candy bar in his pocket melted while he was near a magnetron, and that is a device used in genetic microwaves. From there, he developed his first microwave oven. It was a massive oven, like the size of a refrigerator from what I was reading. Unlike today's microwave ovens using magnetrons to create those microwave frequencies, the waves are directly into a metal chamber that reflect them. So they bounce around and heat the food evenly. Many also use turntables, so they rotate the food to cook it evenly. Over time, microwaves have become much smaller and cheaper and smarter, while some models also include sensors to detect when the food is done or automatically adjust cooking power. Slide 4 is the engineering behind it. So we're going to move into that part and how the microwave actually works and how it is built. At the core of the design, it's the magnetrons, or I might be saying that wrong, magnetrons, which is responsible for converting electrical energy into microwaves. The energy enters the cooking chamber and reflects off the metal wall inside. The walls keep the microwave contained so that the energy is focused only on food, not outside the unit. There's also safety locks that are also engineered in the door. If the door opens, the wave immediately stops, protecting you. So I thought that was pretty cool. Another clever engineering detail is the use of materials. The inside is made of reflective metal, while the outside may be plastic or stainless steel. The window of the door often has a metal mesh built into it. That's why it kind of has that mesh looking thing. With holes that are small enough to block microwaves but still let you see inside. And I thought that was really interesting because I actually never knew really enough about a microwave, and that was just something cool. Microwave engineers are now working on inverted technology for more consistent power control instead of off-on cycling that older models use. If there's something better out there, possibly technologies like infrared ovens and induction heating are alternatives. But the microwave is still fast and the most convenient for most homes. My next slide goes over the mathematics behind the microwave oven. The microwave oven travels at the speed of light, which is about 3.4 times 8 or times 10 over 8 or times 10 8 meters per unit, using the formula that I have on my slides. The wavelength, where there's also wavelength, and c in the equation is the speed of light, and f is the frequency. We get about a 0.122 meter, which is about 12.2 centimeters. That's why many microwaves have turntables, because the wavelength affects heating patterns and can also leave hot, cold spots. Another key formula that cooking is the energy equation, which is times, and then there's mass of the food, temperature change, specific heat capacity, and the power of the microwave unit. And that all forms its own equation for the cooking part. So if you know the mass of your food and how much you want it to heat, you can actually calculate how long it'd take based on the microwave's power. And I thought that was pretty cool. The last part is my reflection. So to wrap up, this project really did actually help me realize how interconnected science, technology, engineering, and math are even the simplest things we use. The microwave oven is not just convenient, it's a product of physics, chemistry, and smart design. It changes how we cook, how fast we eat, and how the kitchen works worldwide. Historically, it was born out of radar technology and is now a kitchen essential, which I thought was really cool. And I gained a whole new appreciation for it, and I hope you like my presentation. And then my last slide are my references, and that is it. So I hope you like my short PowerPoint over the microwave oven.